I'll have to try that next. Is that antenna there specifically?
What I was saying is that I think those antennas, as they were used on ships for spark gap transmitters, were
Yeah.
often just a vertical antenna with a big capacitive hat.
Yeah. Yeah.
Because the true antenna length would have been, miles long.
Well, it's 7 o'clock. Welcome everyone to our sixth and final class. You guys are nearly equipped with everything you're going to need to know to successfully pass the exam on your first try. And very, very glad for that to happen. Oh, there we go. Ah, I got it to move. Okay.
Hey!
Oh, excellent. Oh, that's sweet.
Okay, you can see now how it works.
I
This
can almost hear the music.
this particular antenna is not on your test, but anyway,
It's a great oscillator.
here's our email addresses, and remember, our offer is still good. We're glad to answer questions. If when you're looking at stuff right before your test, you suddenly have a question, send an email to all of us if you want a quick answer, and we'll give you whatever information we can. We are recording. This recording will be sent out probably tomorrow morning. And you guys are familiar with the text we're using and the resources we recommend. Tonight, it's the Bob K06XX show. He's going to be talking about HF antennas mostly, and then a little bit about coaxial cable and some safety stuff. And we'll be talking some more about you guys signing up for your exams. And of course, we absolutely want your questions at any point during the discussion. So before Bob starts, we've got two folks in the class who just passed their general exam and came back to so that we can share in their glory. And I would like it's Howard, KN6KWG, and Ben, KN6NDM. And I'd like each of them to briefly just describe what it was like taking the test virtually. Howard, how was it for you?
It was actually it was great. And I hate tests. I mean, I'm really my age. Taking a test is like, 7 minutes of terror that the rover went through, right, to land. Well, it's a little longer than 7, but anyway. So I had made arrangements to take the exam when I thought that the class was going to be over last week through Anchorage before I knew that San Benito was available. And those folks are terrific. I can't recommend them highly enough. They made things really easy. They were extremely helpful, extremely supportive, and very nice. Very kind to an old man. So it was it was great. What happened was they they called me. I got an email the day before the exam from the person who was going to be the administrator, and she said that she would call me on an hour and a half before the exam. So I thought, uh-oh, an hour and a half before the exam, I'm in trouble. But she called. She had me set up everything, my laptop, and in this case, they also required a side camera. So I used my my phone, and she had me log on to Zoom and checked everything out. Had me, she checked out the room to make sure everything looked okay for the examiners. and she went through everything that was going to happen. She answered my questions. I didn't have very many, and was very, very helpful. And then she said she would send me a text when they were ready for me. Then they did. About my test was due at 10:30 in the morning, and I got the text at like 10 after 10. So they took me early. They had like about 10 or 15 people taking the test. They had everyone, they had it really very well organized. They had me go to a breakout room and actually sent me to a breakout room. And there were the 3 examiners, the one administrator who was, and then 2 others, only one of which was in Alaska. The head examiner was in Wyoming, and the other person was in Texas.
Wow.
And I'm in California, so it was all over the map. And they went through the rigmarole of looking at my ceiling, looking under the desk, looking at my fingernails, whatever. Literally, they had me hold up my wrist to make sure that I wasn't wearing a smartwatch.
Wow.
But they were really nice about it. I mean, they were joking around. I think they were a little embarrassed by all the rigmarole. But in any case, they were also very professional.
Were you nervous, Howard?
I was terrified. Yeah, my age taking a test, I'm way past that. So
and
yeah,
you succeeded. Did they tell you what your score was?
Yeah. What was it? It was like I missed like 5 or 4, something.
Yeah,
like that.
great.
Yeah, so it wasn't bad.
You don't have to get them all right.
No, actually.
That's terrific. Howard, thanks for describing that. And Ben, how was it for you?
Well, if I recall from what Howard and I shared last week, the last experience we had was rather draconian. It was very stringent, and it was very, very nerve-wracking. But once it was all settled and everything was squared away, it was a go. They were very understanding. I went with Silicon Valley, VE. I didn't know anything about San Benito until I talked with you, John, and they were very, very relaxed. I had a 10, they said you can go in at 10 minutes prior to your test. And we did a check-in. I had to do a little bit of form. I did email them prior to say, hey, can I use a wireless keyboard and mouse? Because the previous one was absolutely not. You cannot use an external mouse or a keyboard. It has to be a laptop, because the way you're going to answer your questions you're going to be choosing A, B, C, and D. They were absolutely cool. All they said was, we really want you to pass. And so my next question was, do you have a time limit? Because I had a time limit with my previous one. They said, no, you can take as much time as you want. And so again, they had me do the phone rotation around the room to do a scan up on the ceiling, underneath the desk. I also asked them if I needed to cover the TV, because the previous examiners wanted the TV covered. And they said, no, we're not that. We're pretty relaxed. We just want you to pass. And then they also asked me, do you want to use a calculator? I said, no, I don't want to use a calculator, because I don't intend to answer any of the math questions. I just wanted to make them laugh. And so before I knew it, I was ready to go. And the difference was they did not turn off their cameras. So that was okay. Unlike the previous ones where they actually turned their cameras off. I was totally fine with them watching me. I had my my phone next to where they could see my face and my hands.
Oh, so you could watch them watch you.
Right. So that was it was slightly a little bit like, okay, I'm not going to look at them. I'm just going to focus on the questions, take my time. and get through this. And the beauty of this one was I was able to go back and review all my answers before I hit the submit button.
Huh. Well,
And the other one, I could not do that. It was kind of like a sample test where you just keep going forward and you have no way of going back to change your test, your answers, or just go over them just to make sure that you're confident with it. So,
Well, congratulations, Ben and Howard, our newest
you.
general class license holders.
yeah,
And
thank you. Took me
very
20
s-
minutes to finish it. I got 2 wrong, so.
Oh, you
And did
Very
you say
good.
you went through?
good.
Did you say you went through San Benito,
No, I went through Silicon Valley VE.
Silicon Valley? Okay.
yeah,
Thank you.
And it was at 10, it was 9:30 in the morning on Saturday. So I would say, John, just looking at the San Benito tests or available dates, they all look like they were at 7 o'clock at night. Is that
What I
true?
saw.
So,
Couple at 2.
That was true.
so if for some reason, some of you might not want to do a night test, they do give you an option to do Saturdays, first Saturday and third Saturday of the month. So just something to keep in mind if you want to do a morning test instead.
Had a question in chat. He says iPads or Surface Pro okay for the exam?
You'd have to ask them.
yeah.
I
if you're
used
going-
I used a Mac laptop and a phone for mine. But
So a quick email to the San Benito test address that you have in emails from me, and they'll answer that question. I suspect they can accommodate it, but you should check with them.
also, the Anchorage folks did not watch me. They had me go into the browser and take the test from the browser, and I could also scroll back and forth as well.
Oh, good.
Excellent.
But
Excellent.
it was nice not to have them staring back.
Okay, Bob has a lot of material to cover. So let's, again, congrats to you guys. And soon you will all have your general licenses. I just know that.
Mhm.
Bob, do you want to go ahead, please?
awesome. Congratulations to the ones who passed the exam. That's awesome. Now you don't have to worry about it, and the only time you have to renew is every 10 years. Be sure to renew your licenses every 10 years, everybody. Otherwise, you get to take the exams over again. So it's really important. We're going to cover HF antennas. You know, the HF antennas are really a lot of fun. I really enjoyed them. I had an Elmer who taught me about antennas. He would play around with the antennas. Actually, I had a 3 different Elmers. And the thing is that you can make HF antennas pretty darn cheaply if you really want to know. I've even got a friend that's got a 3D printer who can print up a center insulator and run the wires out and have insulators on each end and call it done. So it's pretty darn good. Let's see here. We're going to go ahead and start in on the questions. What I've been trying to do, I wonder if I can reduce this guy right here. There we go. Nice. Okay. So what we're going to do right off the bat, we're going to start right into it. All there is to it. It's just that simple. If everybody did their studying ahead of time, there's this magic number, and I thought it was really cool. I wish I had known this, which was 2468. Who do we appreciate, right? And what we use is the numbers 4, 6, and 8, and divided by the frequency in which we want to find out what the half-wave is for an antenna. So I'm hoping that everybody did indeed go through these calculations. It's very simple. I mean, I've got my dollar calculator from the dollar store, And I just, did 468 divided by the frequency in megahertz, and I would get the length of the antenna that I needed. Now, something to keep in mind is when they're referring to, let's see if everybody can see my arrow. Can you guys see my arrow?
Mhm.
I think you can. Can anybody see my arrow?
Yes.
Okay. So when they're referring to the half wave length of the antenna, they're not talking about one side or the other side. It's all of the antenna here. It's the whole length of the antenna. This right here happens to be a dipole, mainly because it's got the positive side and the negative side. Usually what we do is we call the positive side the one with the center conductor. The negative is the one with the shield. Although we all know it's AC, right? Alternating current. So it kind of like doesn't matter too much if what side is what. So I just want to let you know that. So this is a dipole. This is really, really simple. So we calculate the half wave dipole in feet by dividing 468 by the frequency in megahertz, which is close enough, 32.8. Now, I think it's interesting that they say 33 foot when actually we're looking at 32.8 feet. When you go to, you can't move that.
Okay.
When you go to make your antennas, I always cut my antennas longer than what I calculate and then trim back from there. The main reason behind that is because there is some interaction between the feed line and the antenna. It's never perfect. I'd rather cut the antenna longer and then trim down with my antenna analyzer or my SWR meter until I get the proper length. So what's the appropriate length for a half wave dipole antenna cut for 14.250,
33 feet.
which, well, that's too fast. How did you do that? You did that really well. Wow, that was really good. So I take, let's see, let me get my cheap calculator here. 468 divided by, and then it is 14.250 equals 32.8. I got it, which happens to be, by the way, on the 20 meter band. So we're going to be looking at a total of 33 feet for the 20 meter band is what we're going to be making that. Next, the approximate length of a half wave dipole cut for 3.55 megahertz is 32 foot. So 3.55 happens to be in the 80 meter band, or sometimes referred to as a 75 meter band for phone. And this is a really great one for nighttime use, or gray line if you want to call that. Now we were talking about 20 meters earlier. 20 meters is sometimes open during the daytime. And as John had said in the past, that the bands are going to be opening more and more and more as we go, because we're at the bottom of the cycle and we're back on our way up. So yay, good deal on that one. We're going to calculate the wavelength on this one. We take 468 by the frequency in megahertz. And we end up, so the total, that's a half of a wave. A half of a wave for 80 meters is approximately 132 foot is what that is. So that's a lot. Now, if you can imagine doing 160 meters, I did it once, but it was a quarter wave, which is equal to a rubber duck. So basically what we're looking at here is on the right-hand side is we have a half wave dipole. We've got a quarter wave on one side and a quarter wave on another, which makes a whole half wave. So in other words, we go by full, half, and quarter wave. Could we make a quarter wave antenna by dividing this as well? Yes, we could. We could actually make a quarter wave dipole as well. This person here is using what's referred to as a line, which is, we'll go a little bit further into that in a little bit, but they're basically using a ladder line for this one here. So basically the answer here would be 132 foot. The advantage of a horizontal polarized is compared to a vertically polarized HF antenna is lower ground reflection losses. So I've had both. I had one antenna that which is a vertical HF antenna. It was called the 5BTV, which was made by Hustler. It had 10 through 80 meters. It was a nice one if you have a limited amount of area, like your backyard or something like that. If you don't have very much room, you can always go with a vertical. It plays fine, really. The thing is that the takeoff angles are different. The vertical will have a lower takeoff. The horizontal, I mean, let's see what else is playing out here. The interesting thing about this is that as you on your horizontal, let me see if I can get my arrow here. There it is. So here's your horizontal dipole right here. As you go up away from the ground, the takeoff angle of your signal is more horizontal. In other words, it's not going straight up in the air. But the closer you get to the ground, the higher that it is, the takeoff angle is. So you'll be actually going up to the ionosphere, which is not necessarily a bad thing. You could be bouncing off of the ionosphere and coming down somewhere else. So it just depends on what you want to do. That's the reason why we have all these different antennas and so on. It depends on what you want to do, what part of the world you want to be in, or if you want to just stay local or what have you. So which of the following is an advantage of a horizontally polarized as compared to a vertically polarized HF antenna? And the advantage is that there's a lower ground reflection loss. What is near vertical incident skyway NBI negation? This is something that for those of you who are planning on being an Aries and as a general, and we're going to be dealing with this eventually sometime, is we are working on getting NVIS antennas for Aries deployment. So this is something that you might want to consider and think about. Let's see here. Propagation near MUF, no short distance, which is in the high frequency or the mid frequency propagation using high elevation angles. Long path, no, I don't think so. Double hop, no, I don't think so. I think it's the second A, yes it is, okay. So it's short distance for mid frequency or high frequency propagation. And there's a whole point behind that. When we're in Aries, we really don't want the whole world listening to if we're doing a race or we're doing emergency, whatever. We use an NBIS antenna. We can actually store local where we're not going quite as far, hopefully. We could bounce off the ionosphere, that's for sure. But we can do ground, what's referred to as ground wave, and stay as local as possible. NBIS, once again, here we go, permits short distance mid-frequency or high frequency propagation using high elevation angles. So in other words, and how you do that is you lower the antenna so it's closer to earth ground, and it will have the higher elevation radiation. Again, here we go again. If we want to go further out, in other words, if we want to lower that angle of takeoff so that it follows along the earth easier, then we're going to raise our antenna higher. We're going to build it up higher. When we want to shorten this up, so here's your little person right here. This looks like it might be about 12 foot or so. And you want to stay local or ground wave, then you'd want to lower your antenna. This is really, like I said before, this is really helpful with Aries, mainly because it makes it easier to set up and easier to take down and so on. So something to think about. Which of the following antenna types will be most effective as near vertical incident sky antenna for skip on 40 meters? And let's see what we got. A horizontal dipole placed between 1/10 and 1/4 wavelength above ground, which happens to be really, really close to the ground, especially 1/10 of a wave. That's really short. They have something that's referred to as a buddy pole, and this is kind of similar to that, where it's a portable half-wave dipole. This right here is your dipole here, and they're very, very handy, but for me, they're really expensive. I can't afford them, but they really are a lot of fun. You can do different configurations and stuff like that with it. Usually the dipole, so if this is where your wire is running right along here is where your wire is running. This is the pattern that your dipole will be transmitting on. This is looking from the top down. So this will be what it looks like. It looks like a figure 8. So let's take a look like a side view. In other words, if we're standing on the earth and we're looking at the antenna from the side, basically what it is as we lower the dipole lowered to the earth, it becomes more and more round. So there'll be just like this red part right here. Now, when we raise it up, then it's going to be more along the lines of this gray line right here. And as you can see, as we go higher up, it also goes further out. So this could be in hundreds of miles right here. Each one of these bands right here could be hundreds of miles. So if we want to stay local, we keep more local. We keep it closer to the ground. And then when we want to go further out, like worldwide and so on like that, we want to raise it up higher. We also have other things that get in the way depending on what the frequency is as well, like trees. If we have trees that are right next to us, that can have an effect as well. Any questions so far? Either everybody's okay or my speaker went out.
Quick question. I had to get to my mute button.
Okay, go ahead.
So dipole, is it referring, when you say dipole, does that refer to the pattern of the energy? Or is it referring to
Usually,
the physical structure?
yeah, usually it's referring to the physical structure of it. So here's one pole right here, and then here's the other pole here, and then die meaning 2. Or if you stick your tongue to the end of this, you could die. So it depends on what kind of definition you want. Okay, I thought it was funny. But as you can see right here, from one insulator to the other insulator is the total length. And then you have your shield on one side and you have your center conductor on the other. Any other questions? Now, the interesting part about this is as we change the height of the antenna also, the impedance changes also. So does the feed point impedance of a half-wave dipole antenna change as the antenna is lowered below 1/4 wave above ground? And the answer is it steadily decreases. Now, there's another way also. There's another way also of changing the impedance of the antenna as well. I'm hoping that'll be shown. If not, we'll talk about it later.
Why is that? Why does the impedance go down as you lower it?
Good question. John, you got any ideas? If John's awake or not.
I'm awake. There's a interaction of the electric field and magnetic field of the antenna with the ground, and as you get closer and closer to ground, the interaction changes. Why exactly does the impedance change? The impedance changes because the coupling to the ground is increasing. I don't know if that helps or not, but
so the ground is kind of like acting as a resistor or something?
the ground, if it's an ideal ground, like
Or-
seawater, for example, a very good conductor.
Or the
it-
conductor, I meant not resistor, conductor. Yeah.
Yeah, no, you're right. The ground resistance actually causes loss from antennas. So you're right about that.
So it
Good,
wouldn't
John.
necessarily be a linear function, right? I mean,
Oh, no, it's quite
Yeah.
complicated.
right.
And you can do all sorts of complicated modeling of this, but in real life, there's so many things going on that you can't measure. The only practical thing to do is try it.
Yep. So this one here, thanks, John. This one here, for me anyway, I call this like a Wyndham antenna. And as we can see, we have a total length here, but we have one leg that's longer than the other. If you guys were to look up Wyndham antenna, it would be similar to what this one is, which has got it's got a balun, which we refer to, as we all know, balanced to unbalanced. The coax is unbalanced and our antenna is balanced. Now, here it doesn't look very balanced at all. So it depends on this transformer as to how it's wound in order to operate with this antenna here. I believe this is going to be a 4-to-1, if I recall correctly. I'm using one Wyndham on my HF rig right now. It plays really well, and it plays on multiple different bands. So I can do 10, 20, and 40 on this antenna with just one line. So that's something for you to think about too. So that's the Wyndham. How does the feed point impedance of a half-wave dipole change as the feed points move from the center towards the ends? The plot thickens. It steadily increases, and that's the reason why usually when you have a dipole, you're going to do a balun that's 1-to-1. That's the ratio of winds from the unbalanced to the balanced. Whereas when you're doing a Wyndham antenna, usually it's a 4-to-1 balun. And I know this is kind of like, you don't have to worry about that. We can talk about that later. Just remember that it steadily increases. The impedance steadily increases. This is the one that I was going to talk about also, which is the inverted V dipole. So basically you got your coax line that's going up here. You got your balun and your insulator right here. And one leg is going to go down here. It's going to tie down here. This is not to ground, by the way. This is not to ground. This is an insulator like a fence, or it can be a post that's going into the ground or what have you. And maybe right in here would be like a rope or something like that. So the interesting thing about this also, depending on the angle of the antenna, depending on how close you are to Earth, you can change the impedance of this antenna as well. As you can see, that's greater than 90 degrees there. This is sometimes called, now this is the inverted V, but it's also the 5, it'll come to me. 5, you know what, I got it and then I don't have it. Anyway, so this is the inverted V. What is the common name for a dipole with a single central support? That would be the inverted V, mainly because we have a mast or something that's going to be holding this up right here in the center.
What happens when you have it 90 degrees instead of greater than 90 degrees? Does
The
it cause
impedance
sonic?
changes. The impedance changes, like I said, and like I said before, and then also John too. You know, it depends on how high the inverted V is, depends on how high the ends are to Earth, depends on the angle of the inverted V that you adjust. So the nice thing about this is that if we want to change the impedance of the antenna, we could change the angles if we wanted to match 50 ohms if we wanted to. But we could also change height and on like how close it is to the ground and so on. Any
So
other
what would you
questions?
change? What would you change first? I mean, it sounds like you go with height, but then you go with angle. I mean, it's just you sort of learn the hard way, or are there
You know,
series?
what I ended up doing is the thing that has always forced me to do it this way is that I'll be lucky if I can, as to how high I can get it. It depends on, you know,
Sure.
what kind of an area I've got and what kind of a mast I've got, what's the mast made of and everything else. Some people put these on top of their roof, and then they run a pole up and then they have the antenna up on their roof. Some people have it on a really tall tower. And so I think the limiting factor is how high can you put it? And then you got to adjust accordingly from there.
Hey, Bob, could
Yeah.
could you center one of these in a tree?
You could actually, yes, indeed. Yeah, this could be a tree right here. In fact, my the Wyndham that I was telling you about that has one short line and one long line, I've got it up in my redwood tree, and then it goes across, and then I've got a rope, and then it goes over to another tree, and it's the same on the other side. So this could be a tree, and it could be going down like this. So this is the tree trunk right here. Just keep in mind too that the tree will have branches, right? So that will change some stuff as well. And you know, there's no hard and fast rule about this. I mean, you know, I think that's the beauty of this, and the real challenge of these antennas is that every single situation is going to be different, and that's the challenge. And it's really a lot of fun because as we learn these things and we try different angles and all that stuff, then we are better prepared for when we want to do something else, like field day or what have you. So
So
yeah,
you need
that
to
is
have it at,
entirely possible.
so you need to have an antenna analyzer to figure out the changes of impedance.
You don't necessarily have to have an antenna analyzer. What I've ended up doing when I was on a shoestring budget is I would just have an SWR meter. There are these fancy antenna analyzers that will test your impedance on the antenna. It will test the capacitance. It will test the feed line and what the impedance of the feed line is, what the you know, just all kinds of stuff. I've got one of those, and they're kind of pricey. They run from about 150 to 200, 300, 400, $500. But when I was first starting out, I just had an SWR meter, and I just set it for the SWR that I wanted for, and called it good. So it just depends on how much money you want to throw at it. Any other questions?
How do you set it? By changing the length of the wires?
What you do is you set the SWR by trimming the edge of the wires. You do that once again. For I cut a little bit long than normal, so I can trim them as I go. It helps really to have a pulley in the middle of your antenna as well. We'll go more into that. If anybody wants to talk about antennas, then let me know. John knows a lot about antennas as well. Most of our Elmers do, but there could be some really creative stuff. Did I answer your question? I'm not sure. I forgot.
Yes, you did. Thank you very much.
Okay. Wow, I'm more than I thought. Okay. So let's see here. We have our dipole, which is this one right here that we talked about before. This is a half wave. Here's our feed line. The feed line could be coax, it could be ladder line, and that would decide as to what kind of balun we're going to be using here. This is a half wave ZEP. And please don't get this confused with the beverage. If you'll notice here on the half wave ZEP, we're end feeding the antenna, but there is no resistor on this side going to ground. So keep that in mind. This can also be called an end fed half wave antenna as well. I actually have two of them, and they're used for SOPI, my RB. They're very easy to set up. I really like them. So that's a different type of, also another type of antenna as well. There's the balun. For some of these, the baluns are at the end here, which is I'm trying to think of what the ratio is. I recall correctly, it's a 90-to-1 balun instead of a 1-to-1. So this one's a 1-to-1. This one's a 90-to-1 balun because the impedance is really high here.
Are baluns like transformers?
Yeah, they are. Exactly. That's right. That's exactly what they are. They're transformers. They will transform like 50 ohms for your feed line. That's right. And it will transform it up anywhere from like, I don't know, 1,000 ohms if they want to, an impedance of 1,000 ohm if they wanted to. So it can be really, really high. Here we go. See, we got one here. That was a 49-to-1 balun right here. So that needs it right there because at this end, it's reading 2,500 ohms and we want to feed it with 50 ohms, right? So we're going to need a 49-to-1 balun, or balanced to unbalanced. So what is the feed point impedance of an end-fed half-wave antenna? We know for a fact that it's very high, right? I mean, if we're talking about a feed line of either 50 ohms or 300 ohms, because, can I do it? Because we're talking about 2,500 ohms on an end fed here, that's really high, right? So that's what we're going to say. We avoid this. It's not very low. It's actually very high.
Which one's correct? A, or A?
Yes, you're absolutely correct.
A, of course.
So that's the reason why you guys are all going to pass the test anyway, because the A is always correct. I didn't have enough time to change these, so, and quite honestly, the letters really don't matter much. It's the actual answer itself. The radiation pattern of a dipole antenna in free space in a plane containing the conductor will be a figure 8 at right angles to the antenna, which is like that. Basically, we're looking at, once again, we're looking at the radiation pattern of a dipole. Here's the wire. Your feed point would be in right dead center, and your radiation pattern would be just like the figure 8. That's one thing to keep in mind too. With your dipole, it's kind of directive, where off of these nulls right here, this is what you refer to as a null in this area right here, you get very little listening power. What is the radiation pattern of a dipole antenna? Is free space in a plane containing the conductor, and of course we're going to have it as the figure 8. Hey John, let's see here. From a portable mobile halo antenna is omnidirectional in the plane of the halo. This is not the magnetic loop really per se. In which direction is the maximum radiation from a portable VHF UHF halo antenna? If I recall correctly, I believe
it's the third.
Yep, omnidirectional in the plane of the halo. It is. We rarely have, rarely ever seen anybody using a halo antenna on a mobile, on a mobile rig. It used to be used a long time ago, if I recall correctly, but we rarely ever use those anymore. But it's on the test, so remember
Bruce
that it's
Dawkins?
omnidirectional in the plane of the halo.
Doesn't Bruce Dawkins have one on his antenna farm, mobile antenna farm?
Who does?
Bruce Dawkins?
Bruce Hawkins?
Hawkins, sorry. Yeah.
Yeah. Why am I not surprised?
The reason you might use a halo is if you wanted to be horizontally polarized from your mobile. But the
True.
convention around here and most places now is to be vertically polarized. So there's no benefit to a halo antenna. In fact, it would be a drawback.
Correct.
How about for receiving the space station?
For receiving the space station, you probably want a small directional antenna, and you want to have an idea where the space station is and aim in its general direction.
Right. So the halo is usually used for mobile for HF, So we're talking about HF antennas instead of the space station. Space station is VHF and UHF, which is much, much higher. Antenna height, do we have any other questions? Okay. Antenna height affects horizontal radiation pattern of a horizontal dipole HF antenna, in that if an antenna is less than a half wave high, the azimuthal pattern is almost omnidirectional. So here we go again. You know, they're just repeating the same thing as we were talking about before. If we're looking at the height of the antenna, so here's the horizontal dipole antenna here, right here. As we go closer to the Earth, it's more of an omnidirectional. Where a rod from the Earth, now the lobes start actually going out further and further, as you can see here.
So for 80 meters, you need a 40-foot high antenna?
At least.
So for 160 meters, what do you do?
Pray.
Yeah, basically is, you know, that's the thing is for me, I was running 160 meters one time with a random wire tuner up in Ben Lonesome. And you know what? I had a quarter wave, 160 meter wire. And I kept walking and I kept walking and I kept walking and I kept walking. You know what? If anybody can string something like that up that high, good luck with that. They've got to be, some are really flat, huge towers. I'm sure somebody got them, but I sure didn't. But I was able to listen. I was able to listen at 160 meters. It's just insane, just insane. So let me know how you do, if you've got the property to do it.
I think I'll be working 40 meters.
Yeah, and you know what? 20 meters isn't bad either. Normally 20 meters is got some really good openings. How does the antenna height affect the horizontal azimuthal? Once again, here we go. Of a horizontal dipole HF antenna. If the antenna is high, the pattern becomes unpredictable. No. Antenna height has no effect on the pattern. That's not true. If the antenna is less than a quarter wavelength high, the azimuthal pattern is almost omnidirectional. And if the antenna is less than a half wavelength high, radiation off the ends of the wire is eliminated. Nope. So it's going to be the letter A. I was right.
Third one.
So it's almost omnidirectional, which means it would be good for Aries, right? If we had an antenna that was pretty close to the ground. Omnidirectional antenna azimuth that best describes radiation pattern of a quarter wave ground plane vertical antenna. Well, here we go again, right? Which of the following describes the radiation pattern of a quarter wave? I got to start moving. That's all there is to it. Quarter wave ground plane vertical antenna. Ooh, my goodness, what is it? Oh, it's omnidirectional in azimuth. So we're calculating again. This time we're doing 28.5 megahertz, which is the 10 meter band. The 10 meter band, which is, if you're when you're a technician, you can actually transmit on this frequency. So we've got 8 feet. Big difference from 80 meters. Let's see if this shows anything. These are the ground radios that can be used for antennas as well. I've got some at my ham shack here, and basically you can have wires that are at a center point here and just running out. Usually they're quarter wave length on the wires as well. It's not necessarily required, but it is a good idea. Okay, so here we go again. As far as what it should be is on the surface of the earth or buried a few inches below the ground. I just lay on the surface. when you're doing the low takeoff angle and so on, the radials just lay on the surface. It's pretty easy. We're going to be talking about Yagis. Yagis are really a lot of fun. Something that this is really pretty simple, really, at least to me anyway, is we have our boom of our antenna, we have our reflector, and we have our driven element right here. As you know, as you can see by the lengths, the driven element is cut to the wavelength that we want using the gamma match. The reflector obviously is larger, so this wave will actually come back and be affected by the reflector and go this way. So it's going to be going up. The director is actually directing the wave that way as well. So this is it's called a 3-element Yagi, is what this is. As you start getting higher in the elements, the actual the wave itself becomes narrower and narrower, and sometimes it's why it's called a beam. Which HF antenna would be best for use in minimizing interference? I would say that it would be the directional antenna. The reasoning behind that is because the pattern for that antenna, there's a lot of rejection on the sides and on the back on a Yagi antenna. So you really can't hear very much on the back or the sides because most of your listening power and your transmitting power is forward. And we have a half wave, of course, again. How does increasing the boom length and adding directors affect the Yagi antenna? The gain increases, keeping in mind too that as you increase the gain and it's going forward and you can hear forward, you hear less and less and less on the sides and from behind you. So you lose some stuff. The main lobe of a directive antenna. Anybody want to take a guess? No? Okay.
A.
The direction of the maximum radius. I'm sorry?
A.
Oh, yeah. There you go. Good job. You got that one. What does the front to back ratio mean in reference to the Yagi antenna? Which means, as we talked about before, the ratio has to do with what we can hear and transmit from the back compared to the front. So the power radiated to the major radiation lobe, which would be towards the front, compared to the power radiated exactly the opposite direction. These are all of them. Which of the following can be adjusted to optimize the forward gain, front to back ratio, or SWR bandwidth of a Yagi antenna? The physical length of the boom, the number of the elements, the spacing of the elements is all of those, which would be A. Which of the following would increase the bandwidth of the Yagi antenna? Larger diameter elements is what it is. It's interesting, even the dipole antennas or any antenna that you make, the larger diameter of anything actually increases the bandwidth. So that's something to keep in mind. So if you had a 22 gauge wire for your antenna, the bandwidth would be really narrow, very narrow. It'd be sometimes referred to as sharp. If I was going to use copper, let's say for instance, 1/4-inch copper tubing instead, my bandwidth would be better. So that's something to be thinking about as well. What is the following advantage of using the gamma matches where the Yagi antenna doesn't require the insulation on the boom? If you ever take a gander at that Yagi antenna, you'll notice that the gamma match and everything else is directly, and there's no interesting. Here's the gamma match we were talking about before, this guy right here. If you'll notice, this element right here is not insulated from the boom at all. You're using this gamma match right here to adjust the SWR to it. Same thing here. The advantage of a vertical stacking horse. You know, I don't know of anybody that actually does this. It is interesting though. I don't know. Gary, have you ever played with these?
John Sisler has them on the satellite trailer. They're not
That makes sense,
they're
right?
horizontal, they're not stacked vertically, but the big contesting stations like K2LR, he's got stacks and stacks and stacks on stacks.
Does he have like lots of money?
He owns DX Engineering.
Okay. Well, there you go. That took care of that. So you get 3D higher gain by stacking them, and especially the single 3-element Yagis. 2 times the gain is 3 dB. What is the advantage of vertical stacking of horizontally polarized Yagis? That narrows the main lobe in elevation. So keep in mind, as we hear more from the front, it becomes the main lobe, or the width of how we can hear things physically is going to be narrow, more narrow. And we already know 3 dB higher, right? What's the primary purpose of antenna traps? There's some vertical antennas, and there's some beams that have what's referred to as traps. They have little coils in them, and those are used to have different bands. So you can have 10, 20, 40 if you want to, by using traps. You use duct in order to do that, to permit the band operation. Which of the following is a disadvantage of a multi-band antenna? Of course, it has harmonics. So because you're radiated at other frequencies as well. So they have poor harmonic rejection. What is one disadvantage of directly fed random wire antenna? And this is really true. We've got to be really, really careful of this one as well. I did random wire antennas as well. I used a random wire antenna tuner, but it was outside of the shack and down on the ground that I was doing it. Because if you're using just a random wire tuner and you're transmitting, you can get RF burns when touching metal objects in your shack. I try to keep the RF out of the shack myself. You can still use a random wire. You can use a random wire tuner. MFJ, Magnified Junk, makes a really simple random wire tuner that handles impedance and capacitance, and you can do that. I would much prefer that. What? Somebody said something. Somebody whispered something.
I heard somebody say what, but I couldn't tell who it was.
Oh, okay. All right. As I talked about before, in order to use a random wire, you're going to need to have an antenna tuner. Some of the tuners are not not able to take random wires. So watch your antenna tuners also if you ever want to play with that. These are the different kinds of antenna tuners. I've got one of these, which is an LDG. It's an automatic tuner. It's really kind of nice. They're affordable. I can set them and I don't have to worry about it. So that's really kind of nice. I also have a manual tuner, which is on the right-hand side. This is made by MFJ. They're affordable, but you have to manually adjust those. I don't mind manually adjusting them. There is a way of doing that where you use low power on your transmitter first, set your SWR, and then you start cranking up the power. And there's the schematic there if you guys want to build your own. Go for it. As we can see, we have a bunch of different inductors right here. If I can find my right here, and those are in line. That was the antenna tuner we were talking about. DBI and DBD. DBI is referring to a isotropic antenna, which is where unicorns live. There is no such thing as a perfect and isotropic antenna, although they get near perfect isotropic antennas. And then DBD is referring to a dipole antenna, which is what we referred to already. And that would be this one right here, which is, so the way I figure this one is DBI is that perfect antenna, right? So a perfect antenna would actually put out more than a real antenna that has to do with reality. So that's what I look at, is I look one right here, okay, the one that's with unicorns and stuff like that is going to be higher because it's perfect in every way, just like Mary Poppins, practically perfect in every way. Now we're going to talk about magnetic loop antennas. John, did you want to talk about anything about these?
I have a couple of pictures of some magnetic loop antennas. Why don't you go through your slides first, and then I'll show some examples.
So we have what's referred to as magnetic loop antenna. John's got one as well. Here is directions does in a small nose indication pattern, and it's to be the broad side of the loop. So this is really interesting how this one is a little bit opposite of a dipole, where the direction, the nulls are actually the broad side of the loop. The nulls are in the broad side of the loop. So that would be, so the signal would actually be coming off of the ends, which I thought was really quite interesting. What is a combined vertical and horizontal polarization pattern of a multi-wavelength horizontal loop antenna, virtually omnidirectional with a lower peak vertical radiation angle than a dipole? All right, John, you want to show what you got?
Yeah, if you let me take off. Okay, you're doing it. Thank you. So I'm the proud owner of a magnetic loop antenna. This is not my antenna, but it's a picture of one like it. This loop here is about a yard in diameter. It's the size of a hula hoop, and you could use it as a hula hoop, except for this stuff here in the middle. It tunes from 40 meters down to 15 meters. So the obvious benefit of a magnetic loop antenna like this is it's really small for a 40-meter antenna, yet it actually works pretty well. It's a good thing. There's some trade-offs that come with that. Here's a picture of the insides of the antenna. This is the loop. This one just happens to be coated with some tape, but it's basically a hoop of aluminum. The antenna's fed. You actually attach your coax to this little loop here, and it couples magnetically to this big loop. Down at this end, there's a very large capacitor. And the secret to making this thing work is to tune the amount of capacitance to resonate in the loop at the frequency of interest. Excuse me, just a second.
What kind of power can you use on something like that? It looks like very high power you're going to arc between the fins of the capacitor.
Yeah, that's exactly right. The thing that limits your power is the voltage across this capacitor. These are very high efficiency devices, but that means they have a very narrow bandwidth. And at this end of the antenna, you get very high voltage. Excuse me, I'm just sneezing here. So to make this thing work, you have to tune the capacitor, which is done with a little electric motor here. It rotates the shaft, and the bandwidth that you get is quite narrow. On 40 meters, I can't move more than about 10 kilohertz without having to retune the antenna. That's a disadvantage. The obvious advantage, though, is that the thing is small, and yet it works really well. So if you've got constraints on how large an antenna you can put up, you live someplace where there's there are homeowners restrictions on what you can do, or if you're renting or something like that, this is a possible solution. The currents that end up flowing at this end of the antenna are very high, and this makes the antennas kind of expensive. The aluminum hoop here is actually heliarced to the capacitor. It's welded in over quite a large area because the resistance here has to be very low. You get very high RF currents circulating in the loop. And to make that practical, then, if you buy a commercial antenna, this is one I got from MFJ, you need some way to tune it remotely. And this is the device that MFJ uses, which it controls this electric motor, which moves the capacitor rotor very, very slowly to form resonance.
What kind of wattage are you talking about?
This one is good for, I think it's rated for 200 watts.
Whoa.
If you want to run higher power, you really have to use a vacuum variable capacitor. And lots of people build these. You can buy a capacitor like this that's inside a glass envelope that's in a vacuum. And that means the plates can be physically closer together without arcing. And the higher power you run, the voltage here goes up as the square of the power. So you end up with some really high voltages here. This also means you want to locate the antenna where no one's going to touch it while you're transmitting, which is generally a good idea for antennas in general.
Where's your antenna at, John?
Sorry?
Where's your antenna at?
When I set it up, I put it on a tripod in my backyard and I raise it up about 10 feet. It turns out they don't need to be very high up in the air to radiate well. I've taken this with me on camping trips too, and it's easy to set up on a tripod as long as you keep the squirrels from running on it while you're transmitting. And it's an excellent, very small space antenna for HF bands, but it's a little complicated, and you need some expensive components to make one.
Hey, John, how does the gain of a magnetic loop compare to a whole?
It's nearly omnidirectional, except for a narrow null in the facing the antenna, so you don't get a lot of gain. That means also you don't need to rotate it, even though it's got a null. Your signal's going out in most of the azimuthal angles. I've never bothered to rotate mine, and I get away with that just fine. I've gotten very good signal reports from it for an omnidirectional antenna, so it actually works better than a vertical antenna, unless you've got really good ground and really good radials under your vertical antenna. Bob showed a picture a few minutes ago of a vertical antenna that had about 60 or 70 ground radials attached to it. And you actually need to do that if you're going to get really good performance from a vertical antenna. On the other hand, verticals don't have any moving parts and they have broader bandwidth, and they have other advantages.
There's always trade-offs. Depends
Can-
on what you want to do.
Can you get a loop antenna that works on 10 meters?
Oh yeah. 10 meters is pretty easy. You can put up a dipole or an inverted V antenna on 10 meters, and it's, you know, the sides are, well, that was one of the examples. The sides are about 8 feet long, right? But yes, you could certainly make a magnetic loop antenna that would cover 10 meters. The one I've got is optimized for the lower frequency bands. I was more interested in that, but there's no reason why you couldn't do that. They're commercially available as well.
They're not cheap. So we're going to be moving on now to quad antennas. I've never built any of these, nor have I ever run one of these, but they are quite interesting. As far as this question is concerned, I think the only thing that I would picture in my mind would be that each of the faces of this antenna, which is where the wire goes all the way around, is a quarter wavelength, so it'd be equal to 1 full wave all the way around. So I would just keep that in mind. Just keep it really, really basic and simple. We can talk more about quads as well. You know, but we're running out of time already, but I mean, you can go on and on and on about these antennas. It's amazing. How does the forward gain of 2 element, I don't know why somebody would do 2 quads. I don't know. So memorize that one. And we're back to the 5% again. If you remember from the Yagi, we were talking about 5% longer for the driven element and 5% smaller or shorter for the 5% longer for the reflector and 5% smaller for the director. And the derivative, they've got the yeah, there's the reflector there. We have a log, what's referred to as a log periodic. I think a lot of people remember this as far as a TV antenna is concerned a long time ago. And basically the different elements would be set for different frequencies and so on. These want to work as well. So that's why they call it a log periodic antenna, is it's logarithmically, wow, that's a good one. Goes along the, which of the following is the advantage of a log periodic antenna? It's going to be a wide bandwidth. We can go further into that as well. It's got to do with how the elements are set into place. Here we go with the beverage antenna we talked about before, and remember where we had the end fed. Now with the beverage antenna, now we've got a terminating resistor that's going to earth ground. And this one's really quite interesting also, directional receiving for the low HF band, so it's directional. Which of the following most limits an HF mobile installation? And I'm going to select this. It's the efficiency of the electric short antenna. So whenever we're working HF, which is really long wave band, you know, as far as physically, the length of it is really long, right? As we saw when we did our calculations. Now with mobile, now we got this really short whip with a coil on it and everything else. Basically, what we're talking about here, everybody, is a rubber duck for HF is what it is. It's a rubber duck. So keep that in mind with HF and a mobile rig. So it's a short antenna. Yep, operating bandwidth might be very limited. In other words, it's really, really sharp as well because we were dealing with such a small antenna. This is what's referred to as a screwdriver. Basically what it is these are coils here. And as the screwdriver, it's got a motor in it, and as the motors, it actually makes it longer or shorter depending on the frequency you're operating at. These are also expensive, by the way. I can't afford one myself. Capacitance, we kind of touched on this before. It actually lengthens the physical part of the short antenna. So that is what the capacitance hat is. If you were ever to buy a 5 VTV, which would be a vertical HF antenna for base station, it capacitance on the top to lengthen that also. The Corona ball, I think let's see what that one is. To reduce RF voltage discharge from the tip of the antenna while transmitting. I don't know if that's used very much as far as, well, it's used sometimes. We'll leave it at that. So it reduces the voltage discharge from the tip of the antenna. Which of the following is to be connected to the antenna analyzer when being used for an SWR measurements? That would be the antenna and the feed line. Usually we consider the whole system. So that would be the antenna and the feed line whenever we do it. This one here is, this is an antenna analyzer that you can buy. It's a little pricey, but I have one. I really like the way it works. It's got a nice display on it. It's called Rig Expert. SWR. So with the SWR, which is the standing wave ratio, basically what we're doing is we're determining the impedance of the coaxial cable on this one. I'm really running out of time. You have this one here. Strong signals from nearby transmitters can affect the accuracy of the measurements, of course, as well as trees. There could be all kinds of things, anything metal that would be really close to it. Even though we're using a metal mast for the antenna, that has some effect to it. If we got right up or near and stuff like that, that will affect it also. Here's a field strength meter. This is actually pretty simple. As you can see, it's got a needle on it, and this is how we can measure the RF output of an antenna and also where the lobes are as well. Which of the following can determine the field strength meter? Radiation pattern of an antenna, so that's what we talked about before. Okay, that's that one. Let's move on to the next one, which is coax. I'm going to go real quick through the coax part. This one I'm not going to have any questions, mainly because we want to really look at what the coax is. I think everybody can pass the test just going through this on your own, but there's some points that we want to talk about on coax in practical use. There's two different types, 50 ohm and 75 ohm. I have used 75 ohm coax before, and believe it or not, if you can ever get a chunk of it from the cable company, sometimes they have remnants when they make a run, and I've actually used 75 ohm coax, which is from the cable company. So there's different kinds of coax. Some are really cheap. This one here is pretty lossy right here. As you can see, the braid is really thin, and it doesn't have a good efficiency. And then we increase as we go, and it also depends on what the dielectric insulator between the two is as well. So keep that in mind. Usually you want to pay a decent price for coax instead of really, really cheap stuff, because your efficiency is going to go down. And our line losses are usually at 100 foot, dB in per 100 foot. This is an eye chart here of the different types of coax and so on. The common one that's used is usually RG58. As you can see, it's pretty lossy. Also the RG8X, which is the 8 mini foam, it's pretty lossy as well. The best you can do is 9913, as you can see here, but it's a big chunk of coax. It's pretty hard. You don't want to kink it. You don't want to kink the coax, otherwise you're going to ruin it. And so as you get higher as far as the efficiency is concerned, the bigger the coax is. I'm going to just whip through this, everybody, because we're running out of time. Sorry about that. So we have different types of feed lines. This one right here is what I refer to as a window line here, which is 450 ohms. This is also parallel two wire line. Actually, I call this ladder line as well because it looks like a ladder. You know, you got your side pieces and then where you step on. Same thing with this one right here, whereas coax. This one's quite interesting. It's different than the coax that we saw before. This is air type of dielectric where they have a piece of plastic that's going there, but basically it's air is going through the center. These are really efficient.
I got a quick question on the window line. What do the cutout squares of plastic gain you on that? Anything?
Yeah, well, it does. It affects the characteristics of the ladder line itself. All of them are different. What we were doing is a while back ago, we were making J-poles, and the characteristics of this change. Basically, what they're doing as far as the cutouts are concerned, as far as I'm concerned, is that they're saving on cost. Instead of having so much plastic, there's no. So what they do is they remove the plastic in the center of these, and each ladder line is different. Everything depends on the size of the wire, the thickness of the plastic, and the spacing between the two wires. But this is basically a balanced line is what it is. So in other words, you got a wire here, you got a wire here, and it's balanced because they're the same size and they're side by side. With coax, it's different. It's unbalanced because you have the center conductor and it's really thin, as you can see, small, but the outside of it is really large in diameter. So it's unbalanced, meaning that both conductors are not the same. Did that answer your question?
Yeah, that's good. Thank you.
Yeah.
Bob,
Yeah.
the gaps in the window line, do those serve a purpose, or do they just help lighten the weight of the coax, assuming that you're going to use lots and lots of it?
So here, basically, this is a feed line is what it is. It'll be coming from the inside of your shack and it'll be going up to where the antenna is.
Okay.
This is what's referred to as balance. The problems with this is, and then what the military found out, is that you can't have this anywhere near metal. In other words, if you have anything, let's say, for instance, your window frame is metal or anything like that, you can't run this because it's going to really mess up your antenna. So you really got to be really careful with this. Whereas the military really liked coax because you could run it next to metal parts everywhere. Let's say a battleship or what have you, they could do that with no problem at all. With the ladder line or the window line, whatever you want to call it, it creates a real huge problem. So this is
the gaps actually change the dielectric constant between the two wires. The ideal line would be two wires with nothing between them except air, but then you would have nothing that would keep the wires exactly the same distance apart for the whole run. So they lower the gaps there actually lower the loss through that line.
And that changes from ladder line to ladder line too, by the way. So if you think that all ladder lines are created equal, that's not true. We found that out the hard way. So now we're talking about antenna tuners, and we're talking about watt meters, standing wave ratio, which is the SWR. It's not SWRs. There's not multiples of them. It's only one standing wave ratio for that antenna. And one of them that you can use is a directional watt meter, where you have your transmitter and you have your watt meter right here, and this is going to the antenna in the feed line. There's a little what do they call that? There's a way where you can reverse which way you want to look at how the power is going out. So in other words, you have the slug. Thank you. There we go. The slug, and you put it in here, and it will read what the forward wave is, and it will read it on the meter. Then when you move the slug and you turn it around, it will only read what's being fed back. And that's how you can calculate as to what the SWR is. It's been around for an incredibly long time. It's very, very accurate. But I like to use more modern things. Here's the one that I was talking about here, which is this guy, which is usually the Bird watt meter. And there's the slug I was telling you about. And as you can see where the arrow is, and you can measure forward or reverse. These are more modern SWR meters here. This one here is one where one needle will read the forward and the other needle will refer to the reflected. And then these red lines right here, it's going to be kind of confusing for some, but after you get used to it, it's okay. Which will give you the actual SWR 1-to-1 or 5-to-1, 1.1 or 3-to-1, so on. These are really handy to have. I've got a couple of them. I have them for VHF and UHF as well. They're pretty cheap on the VHF UHF side. If you don't have one, I would invite you to entertain buying one.
Okay, quick question. The red lines are where the two needles meet? Is that where you?
Yes. Okay. Yep, that's right. Exactly. So this actually charts out what the SWR is. So it'd be 1-to-1 all the way down here. Then you would have 1.2-to-1, 1.3-to-1, 1.4-to-1, and so on, all the way up to infinity right here. You don't want to go any higher than 2-to-1 usually. Otherwise, the radio is going to really hate you and eventually do nasty things where you're going to want to probably buy a radio. Although I must say the more modern radios now, they just will not transmit. So, which is nice. Trust that. Some would say, yeah, it'll shunt the power if it's over a certain SWR, but if somebody keeps playing with it long enough, then that circuit goes out as well. I'm not going to go into this. We're already running short. We can talk more if you'd like. Here's a standing wave ratio of 1-to-1 as a result of the connection of a 50 ohm feed line to a non-reactive load having a 50 ohm impedance as well. So that would be if you have 50 ohms going out from the radio, and you have 50 ohms that's through the antenna system, then you would have a 1-to-1 SWR. And we can go more into this too, but we don't have an hour and a half. So that is the basically here is if you have a antenna that is a ground plane, which is what this one is here, you can actually raise and lower the SWR by changing the radials, the angle of the radials. I think that's pretty cool. There's your calculations. Once again, we have our meters. And we're talking about the red arcs right here. As you can, now you can see them a little bit better. Here's 1 to 2, 1.2 to 1, 1.3, and so on. So this one here is looking about 2.5, 2.2, around there. So let's see here. This needle right here, this one right here is the reflected. This is the amount of power that's coming back to the radio. And then this is the forward power in watts here. So you'll, ideally, if you want a perfect antenna and a feed line system and everything else, it would be down here to 1, a 1 to 1. I love the way they do all these lines. This end connector is really efficient. We don't use them very often. Let's see if we show the other one. So these are all the different kinds of connectors. You know, if you, it's really hard to remember all of these. And when I was first starting out, it was really hard. We originally started out with a BNC connector, which is this guy with a bayonet mount. And that was for the older radios, the older HTs. Then they changed over to the SMA connector. I think everybody remembers that one. Here's the connector. This is usually used for TV. So it would be cable TV is what this one is. Here's an end connector. This has really got good efficiency, but it's mostly used for repeaters and so on. Mostly what I use, what everybody usually uses, is the PL259 connector, which is this guy right here. They have different efficiencies at different frequencies as well. Here we are with SMAs. Here's the PL259. This is the PL259 right here. Any confusion? This is basically what's referred to as a barrel connector. You can put a male here and a male here and change that. The problem with these guys here, I have some of these. The problem is every time that you add the barrel connector, you're actually reducing your power out. I believe, depending on the frequency, but in general, about a half of a dB to 1 dB on this barrel connector. So keep that in mind. If I always like to run my coax, cut my coax a little bit longer, so I don't have to put a barrel connector in. Otherwise, you're going to lose some power. This is a PL259, and this is referred to as an SO238. Okay, we're going to go all this. I'm going to go escape. We're going to go into safety. I'm sorry that I have to rip through this so quickly. I think what we're going to do next time when we do a general is we're going to make some adjustments as to what we're going to do with these guys. We're going to go into safety. Basically, when we talk about electrical RF and electrical safety, there's a lot of common sense on this. Whenever we are working on this and so on, we will turn the transmitter off and we want to disconnect the feed line. You know, there's if you're working with a partner on this, then it really is a good idea to turn the transmitter off and disconnect the feed line. When I was working with microwave with a ham radio friend of mine, we would do that automatically. We never know if the transmitter is going to malfunction or not. There could be nobody at the control point, but something might happen, and so we just disconnect the feed line. We don't want to take any chances, and I would suggest everybody just to do that. Make sure that all the circuits supply power to the tower are locked out and tagged. There's been times when you have a crew of people and somebody says, "Oh, look at this coax, it's not connected to the radio. It's not tagged or anything like that." In other words, it being run or something like that, where it's flagged. and somebody plugs it in, turns it on, doesn't know that somebody's out there actually working on the antenna. So keep that in mind as well. Safety harnesses are really important. I've worn them before. I've climbed up to 75 foot on a tower. It gets kind of scary up there and it gets hard to climb them. Just be really, really careful when you're using the harnesses. Don't ever get on a tower without a harness. I don't care if you're going 10 foot. We would go, usually was the 5 foot range for us. And that's even iffy if you really want to know, especially with an old guy like me. 5 foot probably would kill me, who knows. But if you're going up a tower, just get by a harness, you know, and it needs to be OSHA approved and stuff like that. Make sure you do that.
Bob, are those harnesses one continuous harness, or is that a chest harness and a pelvic harness that connect?
Sometimes it depends on which ones you get. Some have the basic of the harness is that it goes around your hips, and also it's to the point where you can sit on it if you need to, because for you to be on your feet all the time, it can be really, really hard, and you also can lean into it as well. PG&E harnesses are usually leather, which is the one that I had. You could sit on it if you needed to. Mostly you lean back on it. There's usually not a chest section of it, but there is one thing that is on that also, and that is a tether. The tether is really important. Let's say, for instance, something goes wrong with the harness itself. You have a tether also so that it'll catch you.
Thank you.
Yeah. One thing we got to be careful about too is, as far as RF energy is concerned, usually rule of thumb in general, and I'm just saying really, really in general, if you're running an HF rig that's 100 watts and you have people that are quite a 50 so or 100 feet away from the antenna, if you got it up in the air, you don't have to worry about it if you're running 100 watts. When you start running into issues is when you're running higher wattages like 1,000 watts. When you're running 1,000 watts, now we need to start looking at what the radiated power is by using the field strength meter and doing the calculations. This is what's referred to as a horn. Something that's always stuck with me ever since I was really young in the CB days and so on. There was a incident, I'm sure there was many incidences, where there was a horn like this one or a parabolic dish or what have you. They were transmitting when the person was in front of them, and it actually cooked them. I mean, it's a microwave oven, right? It cooked them on the inside and they passed away. So just be really careful with your antennas. You can do the modeling, you can do all of this stuff here. You can do the calculations if you want to. It has to do with time averaging as well and the RF radiation. I mean, this is a lot of stuff that you really need to know to take the test and keep in the back of your mind when you actually are assembling your station. It was interesting. There was a person that I know that put his tower between the two houses, and the antenna was was level with the second story of the neighbor's house. And even at 100 watts, I would be really kind of careful about that one. It was only, I would say, 10 feet away from the wall of the neighbor's house and 10 foot away from the wall of his house on the second story. So just keep that in mind. I'm not going to go into these. How much time have we got? Again, sorry that we're having to rip through these and everything else. There's just a lot of stuff going on here. I want to get into RFI interference as far as neighbors are concerned, because you might run into that when you're doing HF. Here's one here where they've got a fence around it so nobody can come around it. This is a parabolic dish. You're running a lot of power. They're probably running VHF and UHF as well. That's what it looks like to me anyway. We used to joke about that as far as CB radio is concerned, running 1,000 watts and lighting up the neighbor's fluorescent tubes inside the house as you talk. It was interesting. We're talking about GFIs. I think everybody knows what those are. General rule as far as working on electronics and so on is we use one hand. I use my right hand, and left hand is. If you use both hands, then that'll put the current going right through your heart. So you have a better chance of not dying if you use one hand. Usually what I do is I put my left hand in my pocket, and then that way if I'm going to get electrocuted, it actually happens. We had one guy at work at Watkins Johnson. We were working 3-phase. We call him Sparky after that one. He was lucky to be alive. He was actually he reached up across 3 phases, blew out his fingers, and luckily hit off of the circuit. And we thought he was good for dead, but he actually survived. So thank goodness for that, that he only had one. He was reaching up with one hand and laid his hand across all 3 phases. We can talk about, we can all talk about bonding together some other time for grounds. Here's the different gauge. Always look at your charts as far as what your gauge wire is compared to your amps. What I'm doing right now with Sophie is I'm running lithium sulfate batteries, and you got to be really careful as to what the current draw is for charging those, because they'll take a really high current if you don't limit them. So really watch your what your gauge wires are. Different kinds of wire, thick or thin insulation. They have all different kinds of ratings. Interlocks are interesting. I have an X-ray machine at work that I use, and they have interlocks like this. If I open up a door or something like that, it automatically shuts off the transmitter. Yeah, right. Lead solder. You got to be careful to make sure you wash your hands after you do soldering. Here's grounding again. Here's some more grounding. We can talk more about this as you work on your station. Your Elmers know all about this, or should know all about this, so be sure to ask them. We're talking about gasoline generators. If any of you are with CERT, if you have not taken any CERT courses, maybe it'd be a good idea to take a CERT course just for yourself. If you're like dedicated to Aries, then taking a CERT course though is really a good idea to get more information on these. We got generators. The reason these generators for the whole house are commercially connected and so on, that the reasoning behind that in general is because if we have our little portable generators and we hook it to the main house, what we're actually doing is energizing the power lines, and PG&E, when they go to do repairs or something like that, when the power is out, those lines are actually still alive from your generator, and you can actually electrocute them, and that really pisses them off. So it probably would be a good idea to be really careful that you isolate your generator from the power lines. I always keep my gas right next to my generator for a quick refill. In fact, sometimes people, I'm being sarcastic, by the way. I never have my gas tank next to the generator. And there's some people who are stupid enough to actually fill the gas tank in the generator while running, which is hot, putting it hot. And I would strongly suggest you not do that. I've actually seen somebody do this, and it's lit up on fire, and not a good deal. Let's see. Okay, so those are the questions. There's one other thing that I want to mention too, is when you have your HF station and you get neighbors that are going to be that might complain that it's coming over their TV set and so on. I know that some of the old CB radio operators know all about this, but I'm going to say it as well. Is we can be good Samaritans and we can buy the filter for the neighbor, but we do not go into their house. We do not install the filter. They need to have it installed professionally, or they can install it themselves. So the Good Samaritan part is buying the filter. They're really cheap for TVs, stereos, and so on. Is it your fault that they're getting interference? We always need to make sure that our HF station is grounded properly, and it has a really good ground in order to keep that from happening. With that said, also though, that nowadays, and it's been this way for quite some time now, the FCC says, and I think you can see it on some of the warnings and so on, when you buy stereos, TV sets and stuff like that, is it's able to receive interference. And the reasoning behind that is because they've removed all of the filters on the TV sets and the stereos in order to reduce cost for the manufacturer. So if you have a clean running ham station, HF station, what have you, and the neighbor is saying that there's interference, it isn't necessarily you, it's actually their stereo or their TV set because it doesn't have enough filters. So that's what I do, is I buy a filter for them. I say, here's your filter. You can have it installed professionally if you want to, or you can install it yourself. They're really quite easy, actually. But never, never, never go into their house, never install it them or anything, because nowadays they'll say if something happens, it could be a fuse blows or something like that. Has nothing to do with you whatsoever, but they're going to say that you're responsible because you put that filter in their house. So just keep that in mind. That's the number one thing as far as RFI is concerned. So we finished up a little bit earlier. Does anybody have any questions, or do we want to retract, go back to something? You mean I was really that good? Nothing? Nobody? Nobody's got any questions?
Would you mind stop sharing your screen?
I can do that.
Okay, this is the part where I encourage everyone to sign up for an exam. Is there anyone who's having trouble getting an examination time that works for them? Is there anyone who feels like they don't know absolutely everything and the answer to every possible question?
Me, I'm right there with.
Right.
Yeah.
I've got a lot more studying to do.
None of us know everything, but I encourage you to take the test sooner rather than later. We're all busy. You guys have been really good. You're showing up every Monday night, spending 2 hours listening to us talk about all this interesting stuff. But the longer you wait after the class ends, I think the more difficult it'll be. So I encourage everyone to sign up, invest the hour or so of time it takes to take the test. You've got to get your workspace ready according to the directions. And as you heard from a couple of our members tonight, it's actually possible to pass the exam. And in fact, I think all of you will be able to pass the exam.
Absolutely. Yep.
Does anyone not know how to sign up or unclear on how to do it?
All in your email, right?
Absolutely. Yeah, I was gonna show the email on the screen, but I've sent it to all you guys already. It's in the email. The San Benito folks are very easy to work with, and they're eager for you to take your exam, and they're eager for you to pass. Okay, we might be done. Does anyone have any questions, comments, general remarks for the group?
Very good class. I'm really glad I took it. I got a lot of value out of it, and I'm taking the practice exams, and I keep getting a little better. I'm starting to pass them now, so I'm not getting 100% yet, but all of this is very, very helpful.
Excellent, excellent. Don't wait till you're getting 100% on the practice exams. You don't need to be that good.
No.
Just
I'm already scheduled for March 3rd.
Excellent, excellent. This is the first time we've taught the general class. There's a few things that we'll probably do different next time we do this, but thanks for your good questions. Thanks for helping us work out how best to present this material. I have one final request for everyone. Please, when you take your exam, send us an email. You have our email addresses. We want to hear from you. We want to hear that you've passed. If for some strange reason you don't pass, we want to hear that too, because we want to be as helpful as we can possibly be. But you guys are pretty motivated. You all want your general license. And the chances of getting one are greatly improved if you sign up for an exam. So I recommend you all do that.
You guys going to be doing an extra class?
Yeah, absolutely. Get the general and then go for the extra.
Tia was asking if we were going to do an extra class. We may do that if we get enough people that are interested in doing an extra class. And also if there's enough money, if they pay us enough money.
Oh, we do this for free. Don't listen to him.
I'll sign up.
I'll sign up.
I'll sign up.
Yeah.
Yeah.
The general and the extra at the same time. Then we should have like.
Oh yeah.
Okay.
One at a time. One at a time.
You guys go. I'll get you generals, and then come if enough people ask for it, we'll put together an extra class. That's actually. To try to do it well, it's a fair amount of work for us organizing the material, but we love doing this. It's a great hobby, and we want to bring all of you guys into it fully so you can enjoy it.
Dawn and Bob, how much do you charge to take tests?
There you go. Yeah, I would either be a millionaire.
You can buy new toys with all the money you could be making.
No, we can't do that. Every time we try something like that, our noses get longer, and that just doesn't. That we can only use our powers for good.
That's right. Exactly. That's
too bad.
How many watts worth of powers, John? Yeah. Okay. I'll mute.
But thank you very much.
After a while. A really important question, and that is vanity call signs.
Oh,
What is that?
What's the question? How do you get them?
The most important question of all is what's this about vanity call signs?
You mean why bother, or why would anybody care?
Why
No,
would
how do you get them?
No, how do you get them, and how do you get the best ones?
With money.
Yeah, they're all taken.
There are
Go to
there-
go
there-
look,
there-
go to your
there-
car and look at the license plate. There's a website address on every California issued license plate. It's dmv.ca.gov or something like that. That's where you go.
They're asking about vanity call signs, right?
Call signs, yeah.
Yeah, that's an FCC process, and you basically apply the same way you apply when you pass a test. I can't go into it now. If you really want to get a cool call sign, like mine, for example, which I'm forced to admit is really cool. Yeah, to get a short call sign, you need to pass the extra exam. If you want a 1x3 call sign, you guys all qualify for that now, having technician licenses. In fact, Maggie got a great 1x3 call sign, K6 ACT. You just basically fill out a form. You can check with qrz.com to see if the call sign's available. If it's available, you can ask for it, and it's free at this point. Next year there'll be a fee, but it's free now. And my request is don't change your call sign too many times, because I'm easily confused.
I kind of like mine. I wouldn't think about changing it anyway if I got the extra.
Great. Yeah. If any of you are considering getting a vanity call or changing your call sign, do it sooner rather than later, because the longer you go with your current call sign, the more of us know you by that call sign, and the more of a pain it is when you change.
I changed mine right away 20 years ago. I just didn't like my regular one that the FCC issued, so I found a vanity one pretty quickly.
K6 ACE, that's pretty cool.
Yeah.
At the time, I wrote a Honda American Classic Edition, so it kind of fit.
Oh,
there you go.
I figured you were a poker race.
Everything I wanted was already taken, so I basically have to wait for someone to die. And you may be disappointed if you haven't gone looking for vanity plates
What
yet.
is it, 12 years they wait or something like that before it becomes available again?
Once a license expires, either because it's not renewed or because the person is bumped off, there's a 2-year waiting period, and then the call becomes available.
So you look at the ARRL obituaries from 2 years ago. Good.
They publish those in QST.
Yeah, they publish them in QST. Yeah.
That's why.
I wondered why they publish those.
That's the reason. That must be the reason.
Or you can hire a hit.
Well, John and team, thanks so much. We really enjoyed this. You guys put a lot of effort in it, so.
I really appreciate
Thanks.
the effort. Great effort.
Thank you.
Thanks, everyone.
Thanks, guys.
Best way you can thank us is go
Guys.
pass your exam.
Yep. Please
Just
take
have to
your-
teach Bob how to talk faster, that's all.
Yeah, I know. Isn't that the truth?
Larry, the better question
Like an auction,
is,
like an
when
auctioneer.
do-
you know.
The better question, Larry, is when do we have to talk to John only in dots and dashes? You know what
That's the next
gave
thing
us.
on my bucket list was get my general, then learn CW. So
Lots of people really enjoy that, so it's something you
Well,
can explore.
I've got the Gordon West material, so as soon as I pass my test, I'll be working on that.
Great. Well,
Always
if you
something
know
new.
just a little bit of CW, you can get on the air and start using it. There are people who are running at slow rates, or will slow down for someone who asks. If you the magic sign is QRS. Please send slower.
If you want to get, if you want to do CW, I'd really recommend against Gordon West's tapes, because he's going to teach you too slow, and you'll never progress at a faster speed. I would recommend the Long Island CW Club. Google it, and it's very inexpensive, and the classes are available 7 days a week, all hours of the day, and they're self-paced. It's really good.
Good to know. Thanks, Gary.
Yeah.
Is that because the people back east talk real fast?
They talk nice and slow for CW, but no, the classes are really good. I had one instructor of mine was in Thailand. He'd get up at 2 in the morning to teach his class.
Wow.
Oh, boy.
Wow, it's amazing.
All
Great.
right.
We'll say
Good luck,
73.
everyone.
Thanks so much, everyone. Take care.
And let us know when you take your exams. Bye.
Okay, everybody.
Bye.
Thank you.
Bye.
If anyone wants to talk or has more questions, we'll hang on the Zoom for a little bit.
I'm going to bed.
I need to talk to Bob at some point, but I think since Kyle's in the other room, I should probably do that later.
Mikhail can go downstairs or into the living room or something like that if you'd like some privacy.
We can let's set up
Mikhail
a
could
Zoom
sign
meeting.
off.
Let's set up a time because I've got a bunch of stuff to do tonight anyway. I've like 3 Facebook posts I have to create. So
thank you for all your work, Allison, by the way, on all of that. Yeah, let's set up a separate time because this is not the genre for it. Okay, see y'all. Bye.
All right, bye.
Okay, we're down to a manageable number of people. If anyone has any comments or questions, I'll stick around.
I missed how you get a vanity call sign. I get the process as far as going to the ARRL website, but is there a way to determine how you know what a good call sign might be?
Oh, there is actually an excellent website that is more or less dedicated to people who are trolling for available calls that they'd like to get. And well, hang on just a minute. I think I can find it. I've got it in my favorites here. If, talk about something else for a minute. I'll look for it.
Yeah, it's probably the one John's thinking of is probably the same website that I used when I was looking for my vanity call.
Yeah, because the things I can think of aren't within our area. You know, it's
You don't have to get a 6.
Oh, okay.
No, but I recommend you do.
It's less confusing for all of us if you get a 6. But there's
Right.
nothing that requires that you get a 6 call sign anymore.
Okay, that's interesting.
So here's this website. It is Radio QTH, and this is a resource that I used when I was looking for a 1x2 call sign, and it lists calls available by prefix in different formats. It gives information on how to work the process for maximum advantage in order to increase the likelihood that you'll actually get the call sign you apply for. When you apply for a vanity call, you can list, I think, up to 20 call signs that you would accept. And you get the first one on your list that's available.
Okay.
But this Radio QTH site is a good resource. If is that the one that you used, Karen, by the way?
I don't know. It's not looking super familiar.
Okay.
But
there are other sites. If you do a Google search on amateur vanity call sign, you'll very quickly find the 1 or 2 sites that are focused on this. Am I answering your question, Sharon?
Yes, you are. Thank you.
Yeah.
Thank
and
you all for your hard work and dedication to the craft.
we certainly enjoy doing this. You do say your own call sign a lot, as all of you guys know, so it should be something you like.
It's not that I dislike mine. I was just wondering if there's something that's a little shorter.
Yeah, well, you
Yeah.
qualify for a 1x3 call sign. That would be 1 character shorter.
Yeah.
And you might find 3 letters that are useful for you.
Mhm.
Some people I know have their initials as their call sign.
Yeah, I'll look into it. Thank you. Take care.
Okay, good night.
Thanks, Jen. The first letters, there's a limitation on which letters you can use, right?
Yes, it has to be one that the FCC has allocated for amateur call signs, and it has to be one that the International Radio Union has designated for the United States, which
Mhm.
means it's got to be A, K, N, or W.
A, K, N, or W.
Yeah, actually, AA through AM. I think the other A combinations go to other countries.
I was going to say there was something about the A. I was looking up a couple of weeks ago that you could only get the A if you met certain criteria.
I think that's only for extra class licensees.
Mm-hmm. Yes, you're done. Spaghetti on the stove.
Cool. All right. I will see you guys later.
All right, great.
Good night.
Thanks for all
Bye.
your work. Bye.
Our pleasure.